Hello. Oh, I can see there's someone here. I struggle with this topic and can't wait. Oh, good. Okay, I'm glad this is going to be helpful. Um, if the person who's viewing can hear me, let me know as well, because I always have trouble with my audio for these. So before other people arrive, it's good to know that you can actually hear me. But we'll wait for some people to join. So yeah, we will start in a bit. Maybe we won't have so many people today. But yeah, today we're going to be looking at some vectors. We usually start about 5 past, and we wait just a little bit to see if we get some more people. Some people might watch it afterwards, I guess. Hi Bella, nice to see you again. How are you doing? Also, let me know that you can hear me. I'm like notorious for having audio that doesn't work, so the fact you're answering tells me you can probably hear me. I'm good, thank you. Yeah, very good. Hi Lucy. Oh, good. Okay, yes, you can all hear. Fab, yeah. Eventually, on the last session, we have audio that functions. Yeah, how are you all doing? I'm doing quite well. It's sort of had a nice, relatively sunny weekend here. Hello, Alex. Audio is perfect. Fabulous. Good. That means that we're off to a good start today. Yeah, we're doing vectors today. How do you all feel about vectors as a topic? Is it something you're quite confident on? Usually it's one or the other. Usually I find people are either quite confident with it, or it's something that they dread when they see the questions. You've got your math mock tomorrow. I see. So some last minute revision today. I'm guessing vectors will be on your mocks. I'm assuming you wouldn't be here otherwise. So hopefully this will be useful. Hello, Yosef. You hate when fractions come with vectors. I see. So like if there's sort of like a fraction along a line that you lie along. Okay. Bella, you hate vectors. Okay. From what I remember, tell me if I'm wrong, Bella, but from what I remember, most of the topics you've done so far, you felt quite confident with. It's the first time I've heard you say you hated topics, so that means today hopefully will be very useful for you. We talk about velocity acceleration in polar coordinates. Not today, really. This is more the sort of GCSE maths topics. So, yeah, everyone that hates vectors, it's not too hard, trust me. I trust you, Callum. I agree. I think once it clicks, it becomes very easy. But I think it can be when you're learning it, it's so different from the rest of maths that it'd be quite hard to learn and get your head around what you're actually doing. Vectors annoy me. Okay, it sounds like this could be actually quite a useful topic for quite a few people, which is good to know. Yeah, most of them I'm okay with, but vectors is an exception. Okay, that is fair enough. So I think maybe we'll just get started then. So first of all, we'll just go through what vectors are, It's a really basic example. Let me try and get the whiteboard up. So, okay, there we go. Alright, so what vectors are? A vector is just something it has a size to it and a direction. And you can, so for example, if we do like a very simple example, just one vector like this, and if we call it A. There's loads of different ways you can see vectors represented. You either can put a little line underneath it, or it will be shown in bold. Or if we were to like label, just for example, the two end points of the line that is in between, you can just say where you're going from and where you're going to. So this one would be from A to B, and then put a little arrow over the top to show that you're going from A to B and not the other way around. So loads of different notation. It's hard to show bold on a whiteboard, so I'm mainly going to just be underlining. So, okay, so say we have this little vector A. And, oh, sorry, I see in question here, A to B would be minus A. That is completely correct. We're going to get to that really quick in a minute. This little like arrow here is just telling me how I get from, so again, if we go back to calling this A and B, the little vector A is telling me how I get from A to B in one straight step. And the idea of vectors, they're not quite the same as if I'm doing numbers in algebra, where I just have a number without a direction. Vectors, they are just kind of like, if I'm going from London to Liverpool, I'm going to have a certain distance if I draw a diagonal line from London to Liverpool. However, more often than not, I can't just walk through that straight line. So for example, if I wanted to just walk from London to Edinburgh, I'm probably going to have to go around, I'm going to go have some rivers, so I'm probably going to have to find some bridges to go over. If I'm getting the train, I'm going to have to like maybe do like a detour through another city before I can get to Liverpool. I can't necessarily go directly there in a straight line. And with vectors, they're kind of like telling us we can go by all these detours, but what really matters is getting from A to B. And the vector notation is going to be the same regardless of what route I take. So for example, say if I'm going from A to B, this is my direct vector to get there. I could say if I want to go through C and D, I could have some vectors going like this, where this might be C, D, E, and A would be exactly the same as going the detour route. So I could add C plus D plus E together, and it would be exactly the same as if I'd gone from A to B directly. So all that really matters with vectors is getting from one destination to the next. And I can add all these little other directions together to get there, if that makes sense. It will become a bit clearer when we start talking about shapes. But it's quite useful to think of these as if I'm journeying from one point to the other. And I'm just trying to make that journey happen. So let's do a parallelogram. So an actual shape, something similar to a question that you'll see. And let's label all the points on it, A, B, C, and D. And let's call the vector from A to B a little a, and the vector from B to C a little d. And I could use these vectors to describe how to go between any 2 points on this rectangle. And I've just realized I called that D when I said B. Let's change that. So say if I want to go, let's use a different thing here. Say if I want to go from C to D, like so. Morning, Mikhail. So yeah, so if I want to go from C to D, I want to try and use the vectors I already know to describe this route, to come up with an alternative route, because I don't have that vector C to D. If I was going D to C, I could just say it was A, because it's a parallelogram, so the direction of those two lines are the same, or the gradient of those two lines are the same, and also the distance would be the same. However, I'm not going A to B, I'm going the other way around. I'm not going D to C, I'm going C to D. So if I was to write this over here and say A is this way, comparing what I've done to go from A to B to now going the other way, I've just changed direction. And if I change direction with a vector, I change the sign. So that would then be minus A for C to D, because the arrow direction has changed. So say instead that I then want to go diagonally. So I want to go from A to C. I want to find an alternative route again. I don't have that diagonal line. I don't know the length of that diagonal line. I might be able to use geometry to figure it out, but it's not really necessary. I can instead use the vectors that I already know to get from A to C. I can see someone asking what the line under A is. It's just a way of showing that A is a vector. There's different ways you could write it in bold as well, is another way of showing that. So that's all that line means. So yeah, say if I want to go from A to C, and I want to go by a route that includes my vectors I already know. So one way to get there would be to go up and across. And I can just add together the vectors along the way. So to get from A to B, so we say what AC is. Again, notice this is another notation for vectors, just saying where I'm going from and to. A to B was A, B to C was B. And that would be the vector notation for A to C in terms of A and B. We're going to use this and go on to some exam questions. Does anyone have any questions about any of this, anything that doesn't make sense? And if you do, put it in the chat. I will move on because there is a bit of a lag. But if there is anything, just let me know. But what we'll do is we're just going to go on to an exam question over here. Okay, so Mikhail, you're happy with it. So here it's just a 1 mark question. This is when someone was saying about having fractions in vectors. This is kind of a good example of that. Do you have to put the line under A? You could just kind of go over it and make it bold. Technically for vectors, yes, it's good to. In terms of exams in the mark schemes, I don't think they will mark you down if you don't, but it is worth checking for your exam board some of their past mark schemes to check. But technically, yeah, I would put the line under it because going over something and making it bold is quite a lot of effort on paper. So I hope that answers your question, Misam. So yeah, this is where you sometimes get confused. Okay, so we've got here PQR is a straight line. PQ to QR, the ratio is 3:1. And PQ is A. Not just for vectors, generally exams, it's good to kind of go sentence by sentence and either write an equation or annotate a diagram, which is relevant in this case with what that sentence is saying, so that we can follow it. So they're saying that PQ to QR is a ratio of 3:1. So I would actually probably just put that somewhere on my diagram. So a ratio of 3:1. That's supposed to be a 1. And then it tells us that P to Q, and with vectors it's so important that you get the direction correct. So if we're starting from P to Q, the arrow has to be going in the direction that they're saying it goes. And they're telling us that this is A. Okay. So then circle the vector RQ. So again, I would go and annotate the diagram, make sure I draw this in the right direction. So they're saying going from R all the way to Q. So I should draw my arrow to where I'm going, so towards Q. And they're saying, what is this vector in terms of A? We know from our ratio that if we take the direction out of it, that just the size of the line from R to Q or Q to R is a third of the size of the line P to Q. just from the ratio. So our magnitudes of the line, or the size of the line, should be in the ratio that we've got here. So just in terms of the size of this, it's going to be 1/3 of A. And then we want to look at the direction of the arrow and ask ourselves, compared to our vector A, is our direction the same, or has it changed? Has it gone in the opposite direction? So for this one here, you can see, because we're going backwards from R to Q, we have flipped the line over. And when we change the direction of the line, we change the sign of the vector. So instead of being 1/3 A, it should now be -1/3 of A. And for this question, that's going to mean this one here. Let me know if that's okay. I don't know if you can do like little emotes here. If you can put like a thumbs up or a thumbs down if you're happy or not. But this is quite like an important part. This really leads on to all of the rest of vectors. And it's just understanding how you deal with the direction and the size. And you can kind of think of them separately. First the size and then the direction. One other thing with vectors I didn't say is this A. One thing with vectors is you can imagine taking that A as long as it has the same direction and sign. So for example, I could rewrite that A down here. As long as it's the same length and parallel to the one above and going in the same direction, it's still called A. And that's really what we're doing. We can kind of like think of taking them and moving them anywhere, changing the direction and changing the sign. Is this higher or foundation? For most syllabuses, I think vectors come under the higher tier. However, I would double check for what syllabus you're on to make sure. Yeah, I would double check. Sorry, is there a minus because you're going back from R to Q? Exactly, yeah. If you notice A was going left to right, whereas RQ is now going right to left. So whenever I switch directions, I switch signs. And that's why we've got the minus sign now. If they were asking for QR, it would just be 1/3 A with a positive sign. Okay, let's go on to another question, like going up a level of difficulty, really. And so now we have a parallelogram, PQRS. M is the midpoint of PS. Can anyone put in the chat what that means by a midpoint? And I'll wait a little bit. Maybe I'll just read through the rest of the question and wait for people to explain what that means. So midpoint, what does that mean? PM equals A, and they've drawn that on the diagram, and PQ is B. Yeah, Mikhail, the point in the middle. So what that really means is if P to M is A, then M to S is also going to be A. So that tells us that this here is also A. So that's like a bit of useful information that might be useful to us. And that means also that the whole line, P to S, is just double what A is. In between PS, exactly, yeah. So it's really telling us the ratio is 1 to 1 there. Midpoint is half of the line. Okay, good, yeah. Everyone's exactly right. So you see that a lot with vectors, this word midpoint. Just be aware that means that you're going halfway in between the line, or the middle of the line. And find in terms of A and or B what each of these 3 vectors are. So we'll go through them one by one. What colour should we use? Let's use a blue to go from P over to S. And I would also draw the direction of the arrow. So if we're going from P to S, like so, we need our arrow to be pointing towards S, because that's where we're ending up. That's the last letter of the vector notation. If anyone can figure out what that is in terms of A or B, put it in the chat. 2A, Can you zoom in a little bit because you can't see the question? Absolutely. So I hope that makes it a little bit better. Okay. So yeah, I see 2A. That is completely correct. Yeah. You can see that we can do this in 2 steps. To get from P to M was A, and then M to S was another A added on. So it's going to be A for P to M plus another A for M to S, which is going to be 2A. Okay, and then why is M not included in the answer? So M is not the vector. M is just the point. So it's just the point on the line. What they're asking for, and you can tell this because they've got that arrow over P to S, is the actual vector, and A is the vector that they're using to describe it. Okay, so then if we do the next one, I'm going to rub this out to give us a little bit of space on the diagram. So now we want to go from P over to R. So I'm going to try and draw a diagonal. It's probably not going to be perfectly straight. But again, I want my arrow to be pointing towards R. Now this one it's not as easy to look at. It's not going through A or B or any of the vectors I already have. So what I would suggest, and I can see there's an answer already, and some others, good. What I would suggest to people who wouldn't know where to approach this is imagine this is like a line going from a point where you're trying to cross a river. But you can't get there directly. You have to like go across a bridge and then go across a path to get there or something. And you want to find yourself an alternative route using vectors you already know. So what I would do is I would try and follow around the parallelogram. And I would actually stay in the same color. I would say, okay, I know how to get from P to S, which is going to be 2A, which we just worked out. And then I also know how to get from S to R. Because it's a parallelogram, it's just going to be the same as B above. So we can go down and across. So to go down, that's going to be my 2A. And then I add on a B, which is going to be the same as PQ, but now from SR. And that will be my vector notation. So yeah, and yeah, you're all completely correct. 2A plus B. Could you go across and down? Absolutely you could. Yeah, we can show that as well. You'll get to the exact same answer, which is really the whole point of vectors. There's not necessarily one correct route. So we could also go up here, which would be my B, and then down this way, which again is parallel to the other side, and the directions are going the same way as the vectors on the other side. So again, QR will be the same as PS, and that would be another 2A. So yeah, it's completely the same no matter what route I take. Okay, good. So everyone seems to be getting that one, which is great. I'm going to rub all this out again, make some space in the diagram. So then the next one is M to Q. So again, we're going to just write on where we're going from, where we're going to, draw a line between them, and make sure the direction of that line goes towards the final letter Q. So it should be going up this way. Would it be the same if B's arrow was the other way round? That's a really good question, actually. If just to answer your question, Misam, if B was going the other way, then you would be taking it away. So whenever I switch the direction of the arrow, I just change the sign. So okay, so to go from M to Q, again, I want to really find a route that goes in with that uses vectors that I already know. I think the easiest route is probably going up and then across. Again, just imagine this as if you're walking through a park an alternative way, like how you would just get from one point to another and what direction you would go. So if I'm going M to P, notice that I am going in the opposite direction to what A was originally. Because I am going in the opposite direction, I need to change the sign. So that's going to turn from plus A to minus A. And then P to Q is just B, and B is not changing direction, so that is going to be B. So my final vector over here is going to be minus A plus B, which I can see Angel got there, which is perfect. Yeah, so that's that. And again, just to note, with vectors, the fact it doesn't matter. We could have gone the other way. We could have gone the long way around, gone down. Ooh, I can't draw straight lines. Down, across, and up. That would be another route we could have taken, and it would have given us the same result, because then we would have had A to get from M to S, another B to get from S to R, and then from R to Q we would have taken away 2A because it's going in the opposite direction as the vectors that are on the other side parallel to it. And then when we added all this together again, we would have got this. So it really doesn't matter which way round the parallelogram you go, as long as your route gets you from M to Q. Okay, it seems like people have followed along with that pretty well. Let me know again if anyone has any questions. But there is a second part to this. I'm realizing we have 5 minutes, but I think that's plenty of time to go through the next part of this question. Could it be B minus A? Yep, doesn't matter which way around you write the letters, Sam. Yeah, you're completely right. Okay, so this is the same question, same diagram up the top. Now they're telling us that we have point N, which lies on MQ, and we are trying to prove that PNR is a straight line. Imagine that's a straight line. Which would mean that this point here, oops, that was supposed to be pan. That means this point here would be an N. I'm enjoying the lesson all the way to Zambia. That's wonderful. It's really nice to have you here, Daniel, from Zambia. Okay, so we're trying to just prove this is a straight line. With vectors, there's really 2 things you need to prove a line is straight. So first of all, if you think of a whole line and you've got points on a line, everywhere has to be parallel along the line. Everywhere along the line you have to be parallel, which means if I choose any 2 parts of the line, for example here, and then versus the whole line, they should be parallel. With vectors, the way you show vectors are parallel is if one is a multiple of the other. Because if you imagine if I have this vector A, if I do 2A, so 2 of these added together, these 2 are going in the same direction. One is just longer than the other. Can I zoom in again? Yep, of course. Oh, if I can. How do I do it? Oh no. Okay, by doing that, I've disconnected my iPad because I'm not very good with technology, but that's fine. I'm just going to use my old-fashioned touchpad on the laptop. Okay, so can you see this though? So if we want to show 2 are parallel, we need to show that they one is just multiplied by the other. Other thing we have to show is that they share a point. So if you imagine if I have 2 lines that are parallel and also they have any point in common, they have to be the same line. So what we are going to do here is find any 2 vectors that will be on this straight line and show that they are multiples of each other. And the only requirement is that the 2 vectors we find along that line share some kind of point in common. So I think what we choose to find the vector Pn over here. So this vector here. And then we'll also find P to R which is here to here. Thank you all for liking as well. It's really kind of you. It's good to know that you're finding it helpful. Okay, so P to R, so you can see these two would be parallel, and they would also both have point P in common because they both have P in it. So if I can show that these are multiples of each other, we'll have shown that it is a straight line from P to R. So now this is just a matter of doing what we were doing before. So if we want to go from P to N, I'm just going to rub this out so the diagram looks a bit clearer. So we go from P to N. One way we can go is go down from here and then up to here. And notice that they tell us over here what MN is. So that's going to be A plus, and if I really quickly go back, we worked out what MQ was down here. So over here was what MQ was. So we can actually just use this in our answer. So they're telling us that MN is a third of MQ. So we can just do a third of, and I have a memory of a fish. So it was minus A plus B plus B. So if I expand this out, combine all the like terms, we are going to have A minus a third of A, which is going to be 2/3 of A. Doing vector in schools is helpful. I'm glad to hear that. Really wish this lesson was longer. That's good feedback. You can, and there's a link from my tutor, so anything like that is really useful. Oh sorry, not minus 2/3, just 2/3 A, and then minus, no it's not minus, my brain, okay, plus a third B if we just expand it out. Sorry, I'm getting distracted. I'm not like the most focused person. That's good. Okay, so that's going to be P to N. And then if we go from P to R, why is it minus A? The minus A is actually just from what we did in part 3 over here. So all I've done is said that MQ is this. And they tell us that M to N is a third of MQ. So that's where this has come from, a third of what we calculated as MQ in the question before. And a third B just comes from expanding this out. I've done it all in one step. So that's where it's come from. So we minused a third of A, and I just took that away from 1, which is how I got 2/3 A, and then added a third B. So that's P to N. And then P to R, we can, actually I think we worked that out too if we go back. Yeah, we did. So P to R is just 2A plus B, which we've already worked out. So 2A plus B. Now we just want to try and make these two look like the same thing with one multiplied by the other. So I would try and factorize one of them with these questions. We don't really want to factorize this. It already looks quite nice. However, notice here, both of these are over 3. So this is the one I'm going to choose to factorize. And I'm going to take a factor of 1 over 3 out. So 2A. If I take the third out of that, so now if I multiply a third by 2A, I get back the 2/3 plus a third B. What am I talking about? Plus 1B. I'm sorry, I'm getting distracted. Thank you all for being so nice and supportive. It's really kind. So plus B. And now notice that these two are the same vector. It's just that Pn is multiplied by a third. And that's all you really need to do this. It would be quite nice, I wonder if I can get the text box, quite nice to just finish this off with a little sentence saying that Pn is a multiple of PR and both share point P, so PR is a straight line. And that's everything you would ever need to do. These questions come up a lot, so if you can learn this method, it will make these questions so much easier, and they're usually quite a few marks. So we have got like 235 passed, so these are supposed to only be short, quick revision sessions. Thank you all for like being so interactive. This is the last one for the maths course so far. If you found these sessions really helpful, or if you can think of anything we can improve, do use the feedback link that my tutor left in the chat here. Because yeah, it's really, really useful. If you find it useful as well, it helps us to know what to do better. There are still some sessions for computer science and chemistry this week too. So I'm assuming if you're all here for your GCSEs that they will also be helpful for you all. So do go and watch those, and also give the tutors there some good support as well. And yeah, it's been lovely the last 10 weeks to meet you all. And I wish you all the best for your exams. And yeah, I will let you go. Leave us some feedback. Hope this was useful. And yeah, I am going to head off. Please never go. Okay. You've convinced me. Okay. No worries. Yeah, good luck all of you. And I am going to try and remember how to end this. There we go.